Let's try to find the order of each of the elements of the Cartesian or direct product z sub 3 times z sub 4. So let's start with the elements of the individual groups. Let's have here for z sub 3, the elements are 0, 1, and 2. As these are the remainders, if we are going to divide a sum or any integer by 3. For z sub 4, you will have here 0, 1, 2, and 3 on the same concern. Since we have 3 elements for z sub 3 and 4 elements for z sub 4, we are expecting to have an order of 12 for the given group here. Because if we have here z sub 3 times z sub 4, here are the elements. We will have ordered pairs. Using the first here, so you have 0 and all the elements on the second, 0, followed with 0 and 1, 0 and 2, and 0 and 3. These are the first 4 elements of the group. Now, if we're going to move to the second, you will have 1 of 0, then 1 of 1, 1 of 2, let me use some spaces here, 1 of 3. And finally, for the last, you will have 2 and 0, 2 and 1, 2 and 2, and then 2, 3. Let me close this here, or of course I could close this as a whole. In short, there are 12 elements and the order of this group here is actually 12. So let's try to find the order of each of the elements here. If we do that, simply we are trying to come up with a set using each of the elements as generator. But take note that the first entry is for z sub 3 and the second is for z sub 4. We will stop with our generation if we return to this. So that means for the first, 0 and 0. So 0 plus 0 is 0. 0 plus 0 is 0. We ended here because we returned to the element itself. This time, the order of this given element pertains to the number of elements here. So the order of that is just simply 1. So same thing will go for the rest of the 11 elements, and we are going to provide that here. So let's move to 0 and 1. So 0 plus 0 in z sub 3 is 0. 1 plus 1 in z sub 4 is 2. Next, 0 plus 0 is 0. 2 plus 1 is 3. Next, 0 plus 0 is 0. 3 plus 1 is 4, but under z sub 4, that's 0. And then 0 plus 0 is 0. 1 plus 0 is 1. Then we return here, so let's stop here. The order of the element 0, 1 is corresponds to the number of elements here, which is 4. Okay. The third one, 0 and 2. Okay. So 0 plus 0 is 0. 2 plus 2 in z sub 4 is also 0. Then 0 plus 0 is 0. 0 plus 2 is 2. Since we returned here, let's stop. And the order of this element, sorry, that's the parentheses, and this one here is equal to 2. Okay. How about 0 and 3? So start 0 plus 0 is 0. 3 plus 3 is 6 under modulo 4, that's 2. Okay. 0 plus 0 is 0. 2 plus 3 is 5 in modulo 4, that's 1. 0 plus 0 is 0. 1 plus 3 is 4 under modulo 4 is 0. And you have here 0 plus 0 is 0 and 0 plus 3 is 3. We return to here. So close that, and again the order of this element is 4. So we are done with the first 4 and we still have 8. Let me use black here to continue with the spaces here at the bottom. Let's have 1 and 0. So 1 plus 1 under modulo, what they call this one? Under modulo 2 is 0. And 0 plus 0 is 0 here. Then you have, sorry, it's not 0 because we are under, sorry, z sub 3, my bad. So it's not 0 here because 1 plus 1 is still 2. Then 2 plus 1 is 3. That's now it becomes 0. And 0 plus 0 is 0 here. Then 1 plus 0 is 1. 0 plus 0 is 0. So we have here these 3 elements. So, so the order of 1, 0 is 3. Next is, how about 1 and 1? So let's start. 1 plus 1 is 2. For still modulo 3, 1 plus 1 is 2. Next, you will have here 1 plus 2 is 0, modulo 3. 2 plus 1 is 3. Then, 1 plus 0 is 1. 3 plus 1 is 4. That's 0 modulo 4. Then 1 plus 1 is 2. 1 plus 0 is 1. So we haven't returned to this. Let's simply continue. We will end once we return to this element. 2 plus 1 is 3. That's 0 modulo 3. 1 plus 1 is 2 modulo 4. Then 0 plus 1 is 1. That's modulo 3. 1 plus 2 is 3 modulo 4. So you could see that none of the elements are still repeated. So let's continue. How about some spaces here? 1 plus 1 is 2. Then 3 plus 1 is 4. That's 0 modulo 4. And then 2 plus 1 is 3. That's 0 modulo 4. And 0 plus 1 is 1. Next, 1 plus 0 is 1. 1 plus 1 is 2. Okay, good. Next, 1 plus 1 is 2. 2 plus 1 is 3 modulo 4. Then 1 plus 2 is 3. That's 0 modulo 3. And then 3 plus 1 is 4. That's 0 modulo 4. And finally, you have 1 and 1. So with this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Again, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, and 12. So the order of the element 1 and 1 is 12. It matches the order of the original group. Okay? But we are not yet done because the goal here is for each of the element. So let's proceed to, I still have spaces here, so I don't need to worry about that. We still have 1 and 2. Okay? So for 1 and 2, so you will have here 1 plus 1 is 2. 2 plus 2 is 4. That's 0 modulo 4. 1 plus 2 is 0 modulo, what do you call this one? Modulo 3. 2 plus 0 is 2. Okay? So 0 plus 1 is 1. Then 2 plus 2 is another 0 modulo 4. Okay, can we see another element here with an order of 12? Let's find out. 1 plus 1 is 2. And then you will have 2 plus 0 is 2. Then you will have here 1 plus 2 is 0. Modulo 3. 2 plus 3 is 0. Modulo 3. Now, this is your hint. Once you will have the identity, it will surely return to this one, and you will need to add one more element to end your process. So here, the order of 1 and 2, okay, is 6. Okay, it's a 6. Okay, I don't have much spaces here. I think I need to start writing in smaller text size. So you have here 1 and 3. So pardon me. So 1 plus 1 is 2 modulo 3. 3 plus 3 is 6. That's actually 2 modulo 4. 1 plus 2 is 3. That's 0. 2 plus 3 plus 2 or 2 plus 3 is 5. That's 1 modulo 4. Then 0 plus 1 is 1. 1 plus 3 is 4. So 0 modulo 4. 1 plus 1 is 2. And then you will have your 0 plus 3 is 3. So again, your hint is once you reach this one here. Next, 1 plus 2 is 0 modulo 3. 3 plus 3 is 6. That's 2 modulo 4. Then you will have 1. And then 3 plus 2 is 5. That's actually 1 modulo 4. 1 plus 1 is 2. 1 plus 3 is 4. That's 0 modulo 4. Okay, next here, 2 plus 1 is 0 modulo 3. 0 plus 3 is 3. Then you will have here 1. 3 plus 3 is 6. So that's 2 modulo 4. Then 1 plus 1 is another 2. 2 plus 3 is 5. That's 1 modulo 4. 1 plus 2 is 3. That's 0. 3 plus 3 is 0 modulo 4. That's it. Once you reach that, you would know that it would return to the original element. Once you close that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the order of 1 and 3 is also 12. Okay? So pardon me, I still have 4 more elements and I believe I don't have much space here. So let's simply write this in smaller caps as well. So you will have here, we are now at this here, the 2, 0. 2 and 0. So 2 plus 2 is, that's 1 modulo 3. 0 plus 0 is 0. Then 2 plus 1 is 3, so that's 0 modulo 3, and you have 0 here as well. So you stop that. Sorry, you will have to stop it after this. 0 plus 2 is 2, 0 plus 0 is 0. So the order here for 2 and 0 is 3. Next in line, you will have 2 and 1. So you have 2 plus 2 is 1. Modulo 3, 1 plus 1 is 2. Then 2 plus 1 is 3, that's 0. Modulo 3, 2 plus 1 is 3. Then you will have 0 plus 2 is 2. Sorry, that's 2. 3 plus 1 is 4, so 0 modulo 4. 2 plus 2 is another 4, so that's 1 modulo 3. 1 plus 0 is 1. 2 plus 1 is 3, 0 modulo 3. 1 plus 1 is 2 modulo 4. Then you will still have another 2 here, and 2 plus 1 is 3 modulo 4. 2 plus 2 is 4, so another 1. 1 plus 3 is 4, or 0 modulo 4. Then 2 plus 1 is 0. Okay, that's 0 modulo 3. 0 plus 1 is 1. 2 plus 0, again, hopefully that you're having following. 2 plus 0 is 2. 1 plus 1 is 2 modulo 4. 2 plus 2 is 4, but it's under modulo 3, the first one. 2 plus 2 is 4. Under modulo 3, we have 1. And 1 plus 2 is 3. Then 2 plus 1 is 0 modulo 4. Modulo 3. 3 plus 1 is 0 modulo 4. So we have to add the remaining element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the order of 2 and 1 is also, 12. We still have 2 more. So we have 2 and 2. So 2 plus 2 is 1 modulo 3. 2 plus 2 is 0 modulo 4. 2 plus 1 is actually equal to 0 modulo 3. 0 plus 2 is 2. Then 0 plus 2 is 2. 2 plus 2 is 0 modulo 4. 2 plus 2 is another 1 because that's 4. And modulo 3, that's 1. 0 plus 2 is 2. Then 2 plus 1 is 3. That's 0. 2 plus 2 is 4. So 0 modulo 4. And then you will have 2 and 2 as your final. So the order for 2 and 2 is just 6. As for our last, 2 and 3. Okay, I have this small space now. So you will have to bear with me. 2 plus 2 is 4, so that's 1 modulo 3. 3 plus 3 is 6, so that's 2 modulo 4. 2 plus 1 is 0 modulo 3. 3 plus 2 is 5, so that's 1 modulo 4. 0 plus 2 is 2. 3 plus 1 is actually 4, so 0 modulo 4. 2 plus 2 is another 1. 0 plus 3 is 3. Okay? So we have 1 plus 2 is 0 modulo 3. 3 plus 3 is 6, so that's 2 modulo 4. Then 0 plus 2 is 2. 3 plus 2 is 5, so that's 1 modulo 4. We already have 6, so I believe we can still add more. 2 plus 2 is 4, so that's 1 modulo 3. 3 plus 1 is 4, so 0 modulo 4. Then 2 plus 1 is 3, 0. 3 plus 0 is 3. Then 2 plus 0 is 2. 3 plus 3 is 6, so that's 2 modulo 4. Okay, pardon with me. 2 plus 2, or bear with me, 2 plus 2 is 1 modulo 4. 3 plus 2 is 5, so another 1 modulo 4. 1 plus 2 is 3, so 0. That's comma. 1 plus 3 is 4, so 0 modulo 4. And finally, you will have 2 and 3 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the order for the element 2 and 3 is equal to 12. Now, all of these are the answers to this item as we are asked about finding the orders of all the elements of this given Cartesian product. But as you can see, we have 1, this 1 here, 2, 1, 2, we also have 3 here, and 4 elements with order of 12. And take note that the order of this Cartesian product here for direct product z sub 3 and z sub 4 is also 12, because again the order, let me use red, the order of, z sub 3 times z sub 4 is equal to 12. Since 4, or even just 1, but this case 4 elements matches the order of our original group, this group is now been shown to be cyclic. Okay, it's cyclic because it has generators, which are, the generators are 1, 1, we have 1, 3, we have 2, 1, and 2, 3. Okay, so thank you for bearing with me because this is very long. Take note that we are on z3 times z4. What if we have a lot or more than that? Of course, we will have it soon. Thank you very much for watching.